In this lesson we're going to look at a very important number in chemistry called the mole. Now the mole really tells us how many atoms there are present in a given unit of matter. And since atoms are very small indeed, well, we can expect that the mole is a very large number. In fact, the actual value of the mole is this, which as you can see is a bit of a tongue twister. So in order to help us use this number in a practical way, we need to write it in scientific notation. And to do that, what I do is I take the first figure, which is the 6, and then I count the number of decimal places back. And if I do that, I'll come to 23. So I write this figure in scientific notation as 6 and then 0.023 and then times the number of decimal places, which is 10 to the 23. Okay, so how is the mole actually defined? Well, we say this, that the mole is defined as the number of atoms of carbon present in 12 grams of carbon. So for example, we've got 12 grams of carbon here, or even better, 12 grams of diamond, which is made from carbon atoms, as you know. Well then, the number of carbon atoms present will be 6.023 times 10 to the power of 23, or 1 mole of carbon atoms. Now this number is also known as Avogadro's number, and Avogadro was the Italian scientist who first introduced the concept of the mole. And just to give us, an idea of how big this number is, for example, let's suppose that I want to have a mole of dices, and each of these dices is 1 centimeter cubed. Okay, and suppose I want to pack these dices in a cardboard box side by side, layer upon layer. How big would that cardboard box have to be? Well, roughly it would have to be 840 kilometers cubed. That's to say 840 kilometers high by 840 long by 840 kilometers wide. Well, that's getting on for more or less, and it's not quite there, but the length of the UK. So this is a pretty big box that you've got to use to stack that mole of dices. So the mole is really a very big number, and it is defined in this way so that we can say that the mass of 1 mole of atoms of any element in the periodic table is exactly equal to its relative atomic mass. That's to say, 1 mole of copper atoms will weigh, you look on the periodic table, find its relative atomic mass, and that will be 63.55 grams. Likewise, 1 mole of sulfur atoms will weigh 32.06 grams. Okay, we can also talk about a mole of molecules, for example. So, in the same way, a mole of any molecule or compound will weigh the same number of grams, the same mass, as the relative formula mass. So for example, if we take a mole of water molecules, well, we first work out its relative formula mass, remembering that water is H2O, where H is hydrogen and O is for oxygen, and so its relative formula mass will be 2 times 1 gram for hydrogen plus 16 grams for oxygen, which will be equal to 18 grams. That's to say, 1 mole of water molecules will weigh 18 grams. Remembering that the density of water is 1 gram per milliliter, we can also say that 18 grams of water will have a volume of 18 milliliters. So if you pour out 18 milliliters of water into a cup, then you can say that that cup will contain exactly 6.03 times 10 to the 23 molecules of water, or 1 mole of water molecules.